This is an operational amplifier, also known as an op-amp. Despite the name, op-amps are not amplifiers. Instead, it's a comparator, and its job is to compare. It has two inputs, a plus and a minus. If the plus, or non-inverting input is higher, the output will keep going up until it hits the positive power supply rail. If the minus, or inverting input is higher, the output will go down until it hits the negative power supply rail. And if they're exactly the same, the op-amp's output will stay exactly where it is. That's it. That's an op-amp. Let's take a look at some applications. Since op-amps are comparators, let's compare some voltages. Imagine you want to monitor a battery and make a buzzer sound when the voltage drops below 3 volts. We can connect a fixed 3 volt reference to the plus input and the battery to the minus input. As long as the battery voltage is higher than 3 volts, the minus side wins. The output goes low and the buzzer stays quiet. But when the battery falls below 3 volts, the plus input becomes higher, the output swings high, and the buzzer activates. Okay, that's nice. But why is an op-amp called an amplifier then? We're not really amplifying anything. Well, not yet. Let's try something interesting. What happens if we take that output and bring it back around as an input, operating the op-amp with closed loop feedback as opposed to open loop like before? Let's see what happens when we apply 5 volts to the non-inverting input. The op-amp compares its two inputs and sees that the non-inverting side is higher. Thus, the output begins to rise. But as it rises, that same voltage appears at the inverting input through the feedback path. When both inputs match, the output stops changing. And here, it stays at 5 volts. In reality, this sort of transition happens almost instantly. It's just slowed way down here. But wait, it gets better. What if we trick the op-amp into thinking that it is not providing enough voltage? Let's add a small voltage divider between the input and output, such that the input only sees half the voltage of the output. If we apply 5 volts to the non-inverting input now, the output of the op-amp will keep on rising until the input reads 5 volts, which happens when your output reaches 10 volts. Look at that. Now we have an amplifier that doubles your input voltage, and really, depending on how you tune that voltage divider, you can get any type of amplification you want. Well, as long as the output doesn't exceed the voltage on the power rails. Great. Now you know how op-amps work. But what stops us from just using resistors? Why don't we add capacitors as well and get op-amp behavior that's dependent on time and frequency? What happens if we decide to take the output and hook it up to the transistor and have it control things? Think of the possibilities, so stick around. There's more to come.